Today we're going to talk about the beginning of what we call stoichiometry, which is the math of chemistry. In stoichiometry, one of the most important things is understanding how mass in grams and the mole relate to one another. So we're actually going to do some calculations today that allow us to relate those two quantities. In order to do the calculations we're doing after this, you really have to be familiar with what are called gram formula mass calculations, which we're doing today. What's very important to keep in mind is that the masses on the periodic table, we can say that they're in atomic mass units, or AMU, but that is another way of saying that they tell us the number of grams in 1 mole of whatever that substance is. So if you look up sodium's mass, it's about 23. That means 1 mole of sodium has a mass of 23. 1 mole of silver has a mass of about 108 grams. So for compounds, it's going to be a little bit more complex because we're going to have to look at the different elements that are involved. So atomic masses on the periodic table are based on the isotope carbon-12. The formula mass, which we're going to be calculating today, is the mass of 1 mole of a substance expressed in atomic mass units. Actually, to be fair, we actually technically will calculate gram formula masses. This really means the exact same thing. We just then give the mass in grams, or grams per mole. So the unit of a GFM is grams per mole. That's really important, and that's actually going to allow us to do conversions. That becomes a conversion factor for us. So when you hear the abbreviation GFM, don't get confused. Don't make the confused face. GFM stands for gram formula mass. A little sig fig tip when we're doing these GFM calculations technically follow the adding and subtracting rule. So your answer is limited to the least decimal places available. So we're going to start with sodium chloride, or NaCl. You're going to go to your periodic table and find Na's mass, and this is the number of grams per mole we would expect in a mole of sodium. It gives us 22.98977. And that is in AMUs, or we can also call them grams per mole. That's what we'll be using. And chlorine is 35.453 grams per mole. A lot of these I'll kind of skip writing the units all the way through, but it's nice on the first one to kind of have that nice reminder. NaCl has 1 atom of sodium and 1 atom of chlorine in it. So all we really have to do is add these two numbers together. So we're just going to add 22.98977 plus 35.453. And when we add these up together, and remember, we're just going to be able to keep the least number of decimal places we have. When we add these together, we get 58.443. And you're able to keep 3 decimal places here because we are limited by these 3 decimal places right here. And keep in mind, this is in the unit of grams per 1 mole. So next we're going to do C4H10. So you look up the mass of each of these. Oops. We have 4 atoms of carbon involved and 10 atoms of hydrogen in this compound. So what we're going to do now is we're going to do 4 times our 12.011 to represent all of our carbons, and 10 times 1.00794. We are still going to follow the sig fig rules for adding and subtracting. You may be saying, but we're multiplying. Multiplying is a shortcut in this case. We're really just adding 12.01 4 times. We're really just adding 1.00794 10 times. We're not truly actually as a function doing multiplication. So continue to follow your adding and subtracting rules. Keep your decimals the same. In this case, limited by the 3 decimal places that you have right there. So you should have 3 decimal places in this answer. Once you punch all that into your calculator, you get 58.123 grams per mole. Calcium nitrate, which has the formula Ca, that's got a +2 charge, and NO3, which has a -1 charge. So we crisscross that and get CaNO3 too. So calcium's mass is 40.08. Nitrogen's mass 14.0067, and oxygen is 15.9994. In this compound, we have 1 calcium, we have 2 nitrogens, and we have a total of 6 oxygens. Keep in mind this 2 goes to that guy and goes to that guy. So you have to be careful, make sure you have the right number of atoms of each element. So we're going to do 40.08 calcium, there's only 1, so it's just multiplied by 1. For nitrogen, we have 2 nitrogens at 14.0067 each, and 6 oxygens, they're about 16 grams each, or 15.9994. Go ahead, punch these into your calculator. Our limiting factor for decimals here is going to be the 2 decimals in calcium. So we get 164.09 grams per mole. Hydrates are an interesting type of compound. We've seen copper sulfate pentahydrate before. It's those weird blue crystals that we kind of ground up and dehydrated that one time in our physical chemical changes lab. So you actually have the copper sulfate in the middle, and you have physically associated to that several waters. So the way that this compound is written, you have the compound itself, copper sulfate, and then you have this little dot, and then you have those 5 waters. That little dot just means that those are physically associated, not bonded. You may be tempted to multiply the 2 masses together. That dot does not mean multiplication. It means we're actually adding the whole thing together. So for copper sulfate pentahydrate, we've got a lot of masses to look up. So we've got copper, which is 63.546 grams per mole. We've got sulfur, which is 32.065 grams per mole. Oxygen is 15.9994 grams per mole. And hydrogen is 1.00794 grams per mole. We have 1 copper present. We have 1 sulfur present. You can actually opt to do water separately or together with the whole rest of the compound. So in this compound, I have 4 waters right here. This 5 does go out to that oxygen right there, so I actually have 5 waters. If you look back on this visual, what this really means is each of these blues in the water is an oxygen. So we have 1, 2, 3, 4, 5 oxygens here, 6, 7, 8, 9. So we should have a total of 9 oxygens in this compound. Oops. And then this 5 right here is going to that hydrogen. There's 2 hydrogens in each water. So if you go back to this picture again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total hydrogen atoms, and that makes sense based on how that compound is written. You can also opt to do water separately and just add 5 waters onto this. Doesn't really matter as long as you are adding them all up. So 63.546 plus 32.065, so that's the mass of copper, the mass of sulfur, 1 each. We have 9 oxygens, and we have 10 hydrogens. Our limiting factor on this one in terms of our number of decimal places is going to be copper and sulfur both only have 3 decimals, so we'll have 3 decimal places in our answer. When you punch this all into your calculator, you should get 249.69 grams per mole. Here are a few for you to try. Pause the video for a minute, and I will put up the answers and the work for them as soon as you're done. So for KBR, you should have had, sorry, I don't like that in red. For KBR, you should have had 39.0983 plus 79.904, giving you a total of 119.002 grams. So grams per mole. So you're limited by that for your decimal place. Calcium carbonate, 40.08 plus 12.011 on each of those, plus 3 times 15.9994. Our decimal will be limited by this guy right here. It's 10.09 grams per mole. The next one with the ammonium, because we have this 2 right here, we have to remember that those go to each of the things, that goes to each of the things inside the parentheses. So for nitrogen, we're doing 2 times 14.0067. For hydrogen, 8 times 1.00794. And we have our one lonely little oxygen, which is 15.9994. If we add all those together, you should get 52.0763 grams per mole. And this is actually limited by a lot of decimals here, so I guess we're limited by that guy, or really oxygen on this one. And last but not least, I gave you a lot of subscripts to deal with on this one. Your magnesium phosphate. We have 3 magnesiums, each with a mass of 24.305. This 2 goes to our phosphorus, so 2 times 30.97376. 2 also goes to our oxygen, so we have 8 total oxygens, times 15.9994. This gives us a total of 262.858 grams per mole. We're actually limited by our 3 decimal places in magnesium.